Right, question 1. Okay, so we've been given a power spectrum. A PDF probability density function. Okay, and the PDF is this. You don't have to write this down because this is in your question. But we've got K 1 minus x over 30, and also equal to 0. And this is for 20 is less than or equal to x, which is less than or equal to 30. And here we've got elsewhere. Okay. So P of x, okay, my PDF. Between 20 and 30, when x is between 20 and 30, we've got k times by 1 minus x over 30. Okay. And elsewhere I've got 0 as my function. Okay. And it says that, yeah, so the strength of the foundation of a reciprocating machine has been found to be between 20 and 30 newtons per meter squared according to the probability density function. What is the probability of the foundation carrying a load greater than 28 newtons per meter squared? So we need to find first off k, okay, and then we find the probability between 0 and 20, between 20 and 28. And so to do this, we where's my solution's gone? There we go. That's what I'm looking for. So we need to find k first off. So part A, or so the first bit, find k. Okay, so we know that the integral of p of x between minus infinity and infinity px dx equals 1. Okay, so we know that the integral of minus infinity to infinity of k 1 minus x over 30 dx equals 1. Now those limits obviously can be 20 and 30. Okay, and the k can come outside because obviously that's a constant. So we've got 20 and 30 here. Equals 1 minus x over 30 dx. Okay, equals 1. So we've got k integral to 20 and 30 of dx minus k 20 and 30 x over 30 dx equals 1. Now obviously the integral of x in here is just, the integral of 1 is going to be x, so that's going to be 30 minus 20, so that's 10. Okay, minus, and over here we've got k, the integral of x divided by 30, well that's going to be x squared divided by 60 between 20 and 30 equals 1. So we've got 10k minus k. Well, 30 squared is going to be, 30 squared? 900 divided by 60 minus 20 squared, so 400 divided by 60 equals 1. And so we get k 10 minus 8.333, which is that term, equals 1. Therefore, k must therefore be equal to 0.6. Okay, if you can solve that problem, you get k times 1.67. 1 divided by 1.67 gives you 0.6. So that's k, and we've been asked to find the probability okay, that x is less than or equal to 28. And so we do the integration, sorry, it's greater than 28. X is greater than or equal to 28. So we do the integration between 28 and 30 of k 1 minus x over 30 dx. Okay. So k is a constant. So that's going to be k, integral between 28 and 30 of dx, minus k 28 and 30 of x divided by 30 dx. So this equals to k 30 minus 28 minus k, it's going to be x squared divided by 60 . So the integration, certainly for these problems, is actually pretty easy. Integrating x or x squared is relatively straightforward. So the problem was given, we've been given a PDF up here, okay, where between 20 and 30, this was our PDF, is 0 elsewhere. So obviously the area elsewhere is also 0, but between 20 and 30 we have a certain function, okay. We know that the function, if you take the all values, okay, between 20 and 30, okay, because obviously it's 0 elsewhere, we know that the area under that curve must be 1. And so if we take the integral of that, okay, integral of the function there, between 20 and 30, we know that must equal 1. Okay, is a constant, so that can come outside, that's what we're trying to find. You integrate this, you can separate this into two integrals, okay? So we integrate this between 20 and 30, we get x, and then with this one, we get x squared upon 2. Obviously 2 times 30 is 60, so that's where this one comes from. So we've got 10 times per k, because obviously 30 minus 20 is 10. And over here we've got 900 divided by 60 minus 400 divided by 60. Well, that's going to be 500 divided by 60, which is 8.333. Okay. 10 minus 8.333 gives you 1.67. So we've got k times by 1.67 equals 1. And so 1 divided by 1.67 gives you 0.6 for the value for k. And then it says, what is the probability of realizing a foundation carrying a load of greater than 28 newtons per meter? So what's the probability that x is greater than 28? So you integrate between 28 and 30 px, okay? So k again comes outside, you've got these two things. So again, you go through the same process. K, integral of 1 between 28 and 30 gives you obviously x, which is 2 in this case. And here we've got between 20 and 30 of x squared divided by 60. Okay, so 30 squared divided by 60 gives you 15. Okay, and 28 squared divided by 60 gives you 13.067. So we've got 0.6, which is the value of k, times by 15 minus 13.067 gives you 1.16. And obviously over here we've got k times by 2. 0.6 times by 2 is 1.2. So you take that minus that gives you 0.04, which is 4%. So the probability of R realizing that x is greater than or equal to 28 is 4%. Okay. If we were to plot this graph, that makes sense. Okay. We know that we've got a y-intercept over here of 1. Okay, and x is going down by, basically when x is 30 over here, we've got 1 minus 1. So we've got a line that looks like this. And obviously we're looking at between 20 and 30. So that's the area under the curve. Okay, there's my function. That's my PDF, p of x, this is x. Okay, and obviously if I'm looking at 28, we're looking at the tail end of that, any values greater than 28, we're looking at the tail end of that distribution. So there's not going to be very much in that area at the bottom. Okay.